Dear students, good morning. Last class I had discussed on most important part of this chapter. What was that? Force and its effect. Today class I am going to focus you on very important topic, Newton's first law of motion. Galileo's attempt to study nature of force and motion was very successful. It was Galileo who formulated a concept, inertia at first. That means law of inertia, also called Newton's first law of motion, a postulate in physics, was first formulated by Galileo for horizontal motion of objects on Earth. Before Galileo, it had been thought that all horizontal motion required a direct course. But Galileo deduced from his experiment that a body in motion would remain in motion unless a force such as friction caused it to come to rest. This natural tendency of a body to continue in the state, that is motion, unless the frictional force caused it to come to rest is inertia. The formulation of inertia, one of the greatest contributions of Galileo, helped to lay a foundation to development of laws of motion, which were proposed by Sir Isaac Newton. By observing the motion of an object on an inclined plane from his experiment, Galileo deduced that objects move with a constant speed when a force acts on it. Now you are going to study about the deduced statement made by Galileo as a result of his experiment and how can we demonstrate the concept inertia with the help of Galileo's experimental method. According to Galileo, an object moves with a constant speed when no forces act on them. This means if an object is moving on a frictionless path and no other force is acting upon it, then the object would be moving forever. That is, there is no unbalanced force acting on the object. It can be explained with the help of an activity. Take two identical wooden boards, place them against each other on a table in such a way that they make equal inclinations with the table. Assume that surfaces of the wooden boards are frictionless. Now take a marble and release it from one inclined plane on left side. You see that the marble rolls down and moves upon the second inclined plane. Now you think about how far it moves along the second plane when the slope for both surfaces are same. It is seen that it moves with the same distance and reaches to the same height when it is released. Now we decrease the inclination of the second plane and release the same ball again from left. What can you observe? It travels with a large distance to reach the original height. Now we can keep on decreasing the slope of second inclined plane, and what will happen when its slope eventually reduces to zero, that is, it makes horizontal, then the marble will continue to move forever until it reaches to the original height, but practically it is impossible to achieve the zero unbalanced force, that is force of friction. This activity points out that the marble ball should be in uniform motion forever, as it has been assumed to be applied an experimental condition such as no external unbalanced force. Here force of friction acts on the marble ball, and also this activity shows that the ball will never reach to the original height though it tries to reach it. But actually in practical situation, it is not possible to achieve a zero unbalanced force. This is because of the presence of frictional force acting opposite to the direction of motion of the marble ball. Thus, the marble ball stops after traveling some distance. But the effect of the frictional force can be minimized by using a smooth marble ball and a smooth plane and providing a lubricant on top of planes. Later on, Newton studied Galileo's ideas on force and motion and formulated three fundamental laws that govern the motion of objects. These three laws of motion are known as Newton's laws of motion. On next part, I am going to discuss on Newton's first law of motion. What is Newton's first law of motion? For all the physical activities that you observe in the slide, an effort is required to put a stationary object into motion and stop a moving object. You see that a kicked football rolls on the ground and comes to halt naturally. It is due to the frictional force applied by the ground on the ball. On the other hand, if friction does not exist or it does not stop the ball, it would move continuously forever. Newton used the Galileo's experimental conclusion on inertia and proposed his famous first law of motion. What is his statement? It states that a body continues to be in its state of rest or of uniform motion in a straight line unless compelled to change the state by an external unbalanced applied force. If you see again at the tug of war competition, you would see the two teams pulling the rope in opposite directions. If the rope does not move at all, forces applied by each of teams are balanced forces. If one of teams applies a greater force, second team will move towards the first team. In this case, forces are unbalanced and two forces are in unequal magnitudes and in opposite directions. The second team moves in the direction of greater force applied by the first team. If one of the team leaves the rope, the opposite team falls backward. This backward motion is due to inertia. That is, if an object which is in rest, it will remain in rest, and if it is in motion, it will be always in motion. This natural property of a body is called inertia. Inertia is classified into three types. They are first inertia of rest, second one inertia of direction, and third one inertia of motion. Certain experiences that we encounter while traveling in a bus can be explained on the basis of law of inertia. The passenger standing in a bus tends to move backwards when the bus begins to move suddenly. Why does it happen? This is due to inertia of rest experienced by the passenger in upper part of his body. That is, the upper part opposes this motion because of his inertia. But as his feet in contact with the floor of the bus makes the lower part of his body move along with the bus. The inertia of rest is the tendency of a body to resist any change in state of rest. What will happen when a fast moving bus is negotiating on a right curved road? The passenger will tilt left side. This is due to inertia of direction of his body. The passenger tends to continue in straight line motion due to this inertia when engine of the bus changes its direction. What will happen to the standing passenger when sudden brake is applied by bus driver? The passenger tends to fall forward. With the application of brakes, the upper part of his body will continue to be in motion and lower part will come to halt along with the bus due to the contact of his feet with the bus floor. Here, the upper part of his body tends to continue in the same state of motion because of his inertia. It opposes any change in state of its motion. This tendency is called inertia of motion. Once again, I say about the classification of inertia. There are three types. First one, inertia of rest. Second one, inertia of motion. And third one, inertia of direction. First one, inertia of rest. The inability of a body to change by itself is the inertia of rest. It means a body at a rest remains at a rest and cannot start moving on its own. See the situation when a bus starts suddenly from rest. Second one is inertia of motion. A body in motion remains in motion and cannot stop on its own. A body in motion opposes the which try to stop it. See the situation when a bus stops suddenly. And third one is inertia of direction. A body moving along a straight line will continue to move along the straight line until an external force changes its direction. A body moving along a straight line will oppose the forces which try to change its direction. And understand the situation I told in earlier session, that is when a bus is negotiating on right curved road. On its summary part, I ask you, can you state Newton's first law of motion? Newton's first law of motion states that objects at rest remain at rest and objects in motion remain in motion at a constant velocity along a straight line unless acted upon by an external unbalanced force to change their state. Dear students, today's questions as your homework are: first one, who formulated law of inertia at first? Second one, what was conclusion drawn by Galileo from his experiment by using inclined planes? Third one, what is inertia? How many types of inertia are there? What are they? Fourth one, state Newton's first law of motion. And fifth one, give 3 examples exhibiting law of inertia, that is Newton's first law of motion, in our daily life. I expect all of you will work out the homework given and study the question answers up to date. Okay, thank you. Have a nice day.